Goal in preparing MAN BMW camshaft-less computer-controlled engine familiarization course is to have something for everybody, for all marine engineers, for serving and future marine engineers, for the educational purposes. This course costs a lot, so my intention was to make it affordable for all people, all engineers across the board, juniors, seniors, so that they can learn something. They can familiarize themselves. However, a voluntary contribution and donation is welcome, whosoever wants, whenever they want. And it's also encouraged. Also gives your feedback after you complete each chapter. That will help me make changes, improve the course, so that the other people can also can always get benefited. Thank you very much. EICU, Engine Interface Control Unit. So it is an MPC. We call it MPC. What is an MPC? Multi-purpose controller. Electronically controlled. It's a electronic hardware. EICU is an interface between safety shutdown, throwdown interface, and also third-party remote control system. So Kongsberg Auto Chip with the ECS remote control system interface with ECS is also through EICS. It's not EICS, EICU. Mistakenly written EICU. Correct it, please. ECU, it is an MPC, multi-purpose controller again. One more part of the ECS, of course, engine control system. ECU controls start, stop logic. That means it will start, signal will only go to the CCU when all the requirement for the starting are met. Start block will exist. That means nothing will go to the CCU. No signal will go, no data will go to CCU if start block condition exists. For example, turning gear is engaged. All right. Or starting air valve is not in the starting position, manually closed. All right. And there are there are pre-starting position here, or you can say blow through kind of thing, slow turning and manual air run. These are the two different things. I'll tell you what is slow turning and what is manual air run. ECU also carry out function of the governor. Remember, I told you governor is not there. So the governor functions are carried out by the ECU. It is the processor which carries out the amount of fuel which need to be entered to the unit. CCU will just direct as calculated by the ECU. All right. Or limit the amount of fuel as required or as required by the limiter in use. Limiters will say, let's say chief engineer put a limit. What limit? The RPM not to go for more than, suppose the engine running RPM 80. Now you want to run the engine, let's say 75 RPM, no more, for whatever reason. So we'll put how we will control the RPM, that not to go more than 75. He'll put a limit on the fuel to be released into the for the unit, for all the units. So it's called limit. In this engine also we have a limit. We call it chief limiter. So it limits the fuel as required. If the limiter in use, so that we decide by the ECU. It also controls the engine running modes. They are running mode. We'll see what are the running mode: RPM mode, index mode, allo. That we'll see. Fuel index mode, RPM mode. ECU is auxiliary control unit. It is again an MPC, multi-purpose controller, part of the ECS engine control system, which controls the functioning of the sum of the diesel engine, which are necessary for running the engine, like operation and control of auxiliary blowers and electric motor engine-driven hydraulic pump. Hydraulic pump in ME engines are two types, of course: electric motors driven by electric motor Of course, before starting engine, there is no hydraulic pressure. So you have to have electric motor. And when the engine is running, a certain RPM engine is picked up, pumps which are connected to the engine directly, they will come into play and build up the hydraulic pressure. So they are engine driven hydraulic pump. Depending on the size of the engine, number of units, there are different types of different pumps. For example, MEB engine, usually no engine driven pumps are used, only electric motors are used, just for your information. Primarily, we'll talk about here MEC engine only, not MEB engine. Okay. CCU. CCU is cylinder control unit. It's again a multi-purpose controller. Yet another part of the ECS, yes, engine control system. ECU, CCU controls unit-specific function: fuel injection, exhaust fuel actuation, cylinder lubrication, and starting air valve. The four functions are basically carried out by CCU. All right. So, what been talking about MPC? What is an MPC? MPC is multi-purpose controller. All this controller we have talked about, ECU, EACU, CCU, and ACU, are multi-purpose controllers. And they're exactly same. Huh? What do you say? Exactly same? Yes, they are exactly same hardware-wise. But they use different software to carry out the different tasks which they are supposed to carry out. So they are exactly same, but their construction is same, hardware. They use different software. How do they use the different software? They are directed to download the software from the engine control system, which is in the MOP. When you put the MPC in place and use an ID key, dongle also it is called. Depending, dongle has got a small program already pre-written. Basis that program will initiate and tell the engine control system or MOP what kind of software to be download to this particular MPC, which let us say ECU or EACU or CCU. Isn't it interesting? Yes. But there is small little change. All the MPCs were same initially, but later on what they did, for CCU, they redesigned the MPC. MPC for CCU are redesigned, a new version, MPC 10 they call it, is being used now. So depending on the ship you are, you may have a CCU, MPC for CCU, which is same as other MPCs, or you may have a MPC for CCU, which is different. That means MPC 10. So MPC is basically, this was done for the cost optimization basis. All right. And only four functions need to be carried out by the CCU, so they made it simpler, which is cheaper also. I think it's something it costs about $8,000, something like that. I'm not very sure. Other MPCs call out $10,000, $12,000, maybe $15,000. It's different than all other MPCs. All right. MOP. MOP is main operating panel, and it is called HMI. What is HMI? Human machine interface. Who is a human? Operator, engineer, person who are running the engine. And machine, our control system. So the duty engineer or engineers will interact with MOP because it's a computer. Computer need to be given commands, and computer can read only machine readable signal. So that direction, human can give direction to the MOP, and MOP will in a way forward this message to the required MPC. So two MOP are provided, of course, for redundancy. One of the MOP has a touch screen. Other one is simple, ordinary, normal PC. It can also have a MOP screen, no, depending on the owner, how much money he wants to spend, or his maintenance philosophy, his operation philosophy. Touch screen is used for various input which operator need to give. But actually, you do not have to touch the screen physically. Because why? Because it has got a infrared elevated screen. That means when you take your finger near to the screen, where you have taken, that particular point will get your signal. So actual signal screen is little bit elevated by the infrared grid. Okay. Therefore, an operator does not necessarily need to touch the screen. This is done for the normal, real, actual reason, because engineers' hands might be oily, greasy, things like that. We work, we work with our hands. So that's why. But now, even if you touch it, doesn't matter. You can always clean it. Try not to touch it. Keep it clean. So MOP is the main interface for the engineer operating the engine. MOP communicates with the controller of the ACS. All the control which we're talking about, AICU, ECU, ACU, CCU, or the control network ANP. The two control network always in place, always working, always available, always we call hot standby. But remember, in this only MOP-B is equipped with Ethernet card. Why we need Ethernet card? Internet. If you want to send data to external sources, to your office, for example, or we have what is called CoCoS-EDS. We'll talk about CoCoS, what? Computer control, computer surveillance, inject diagnostic system. Inject diagnostic system is a self-diagnostic system. For that, we have Ethernet card. Remember, follow cyber security of your policy of your company all the time. You don't want your system, computer to get some virus, some Trojan or something infect your system, you will have trouble. All right. Nothing, this is normal. I mean, understandable. Why you like to infect your most important assistant on the ship, isn't it? LOP. LOP is local operating panel. It's a kind of replacement for the local control stand for conventional engine, but not exactly same. Engine can be controlled from either the bridge, ECR, or local station. That is LOP. Either LOP, of course, as in the standard convention thing, has a you can take the force command take over. All right, you don't have to go to bridge or in control room and put on the LOP, then only use LOP. No, you can, even if something happens, you are nearby or go to LOP, you can take command forcibly also. ECU is directly connected to the LOP. Engine is directly connected to LOP. ECU is actually the brain and running the engine. Therefore, if remote control fails or some problem with the bridge and ECR control, engine can be operated from LOP. But you cannot change the parameters. You cannot change the parameter. You want to advance and retard the injection timing, you cannot do from LOP. Because for that, you need HMI, human machine interface. LOP is not human machine interface. Other beauty is MOP takes your data, takes your input, and transfer your input, your command to the engine control system. But MOP is not required for running the engine. You can switch it off. Because when the control system has got your data, they will keep running. MOP is only machine interface between you and the control system. Such as so, but from LOP, the basic function available, you can control speed. Starting everything you can control, stopping, reversing, important engine data are displayed. Low well pressure, starting air, etc. are available. But parameter cannot be adjusted. All right. Also, what is the difference between bridge control and engine control? Engine control for a local control system. Let's say conventional engine. What is the difference? Do you know? Yes. You can tell me. Yes. What is the difference? Remote control and engine control. In a conventional engine, not M engine, normal engine, which you have been sailing on. Yes, you're right. Similarly, here, remote control and engine control system. in the engine control, there are two systems actually. I'm taking extra, which is not written here. Engine control room control, and backup. Control of the engine from remote, that means from the bridge or the engine control, is same, no different. Backup control is hardwired. Backup control is hardwired. Engine and bridge control is where the command is data driven. Data signal is sent. And backup control from the engine control is hardwired, that is analog signal will go. You understand the difference? Like electronic and pneumatic control, which you had the bridge control and the engine control. Yes, you got it. Very good. So now we have a tacho system. There are two redundant tacho systems. Tacho system A connected to ECU A and tacho system B connected to ECU B. This is what I was talking about, crankshaft sensor system, which tells the engine control system which unit is in what position with respect to the crankshaft, so that engine control system can decide where the injection to take place, which unit air to send, which unit exhaust valve to open, or reversing to take place accordingly. So they have crank angle encoders. There are two angle encoders. Then we have a marker master, marker system, marker slave. All right. Okay. Q1, quadrature sensor 1, quadrature sensor 2. C, as I said, crank angle encoder. There are two angle encoders. Both must be available. Or both are working. At least one must be available. One must be working. Otherwise, you cannot start your engine. You cannot start your engine. As that's naturally one must be there in the spare also. Otherwise, you're stuck. Your engine is dead, middle of the ocean. Since there is no camshaft or no cam which operates fuel pump to inject fuel exhaust actuator cam, ECS must know the position of the individual unit, as I was just saying, with respect to the crankshaft. Otherwise, something like engine is blind. What to do? So that precise time for the fuel injection and opening closing of the exhaust valve can be determined. This is achieved by installing two crank angle sensors at the free end side. Two sensors are used for redundancy, naturally. Two are required. Needless to say, one of the crank angle sensor must be working, otherwise engine cannot be operated. All right. So one is always in the sphere. All right. So marker master a marker slave A, also B. We'll talk detail. This is only introduction. I'll explain all in when we go ahead. CoCoS-EDS. All right. Computer control surveillance engine diagnosis system. Two versions of the system are available. Both are available on MOP B. This is not available on MOP A, MOP B, which is connected to Ethernet. है ना? Okay. CoCoS-EDS ME basic. There are two versions of CoCoS-EDS, basic version and advanced version or something. This is mandatory for MEC and MEP engine. All versions this is fitted, company fitted, you can say. Nothing else is needed by the engineers and available when engine is delivered. It is installed since it is a mandatory version. Naturally, it is installed. It has interface with engine control system and PMI, online or offline. PMI also online or offline. There are two methods. This also we'll talk about. A log and display of the data from the ACS is available. It is used for condition monitoring, as data is available for long period. It can be used for condition monitoring also, provided sensor is fitted. For example, liner wear or liner wear. Recording of data, All alarms are always recorded, more than a million. So you can compare the trends also, because all the data is available. What has been happening last 2 years, 5 years, 6 years, 1 year, something like that. Available data can be reported also. For example, some alarms is some incidents have taken place. Company wants, okay, what happened? Send us data for the last 1 week so that we can analyze, or we can send to the experts, get their opinion. 1 week data you can select and send to the office. Of course, using MOPB Ethernet. Also used for adjustment of a parameter. What was when engine where everything was running normal, this was the data, this was the parameter. Now we change something else has happened. Let's go back and check what was the data before. So this information available on the PC, and it's a window based. User can easily navigate the menu and get trends. We all are used to using the Windows system. All are expert now using PCs. There are time in our time when we were saying some people left C because this company said now you have to use computers. They said, oh, we don't know how to use computers. So always move with the times. Learn. Never stop learning. So the information available on a PC and is window based. User can easily navigate the menu and get trends, compare past data, see the trends, and much more. All right. CoCoS-EDS ME full version. There is much more. You get much more from there. Operation and as per the owner requirement. Of course, the owner has to pay for it. This version also shares the similar software for monitoring, adjustment, and troubleshooting of the engine as the basic version. Additionally, the main difference is the configuration of the software and the interface towards other systems. For example, alarm and monitoring system. Interface to other system, alarm monitoring to log cylinder exhaust temperature, bearing wear monitoring, liner wear monitoring. So you can base your maintenance on condition-based monitoring, condition-based maintenance. Reference measurement of model curves for enhanced troubleshooting. Model curves are available. So which can be used for reference purposes. Or auto tuning. Instead of you tuning, it can be continuously tuned. Performance analysis diagnostics is also available. Full version is always commissioned by the service engineer on request and cannot be done by the shift staff. All right. A basic version is already pre-installed.